Okay, hello everyone. This is the Geogebra simulation that I have created for Newton's law of motion. Okay, so to start things off, can show you all the left column. So the left columns are variables that I've created like in order to create the simulations, and then after that, um, the simulation right is based on the real life phenomenon of two-person on their own skateboard. Then when person A push person B, the two-person will move in opposite direction lah. Yeah, so I think this is something that we can start off lah, right? To for the students lah, right? To predict like how they will move like. Yeah, so the blue box is A, and then after you have body B, you check here, and then after that we can move on to the input boxes first. So the box size will adjust accordingly lah based on the mass, right? So let's say A is you want it to be 150, it will adjust accordingly lah. Yeah. Okay. And then after that, the time will be the main variable for the animation to occur. Force you can also adjust. I put frictional and opposing force because there will be different scenarios lah. Using the same example, we can have different scenarios lor. Yeah. Okay. Whatever you do, always press the reset first before you want to try anything else lah. Yeah, okay, so if you want to just show the phenomenon to the students, right, what you can do is you can just press start, okay, and the body will just move. The boxes will move, right? And you will just keep moving. Why? Because there is no friction. Yeah. But then after that, you can also add friction to simulate real life. You will start, you see the friction become 40, and you start, the boxes will move and then it will stop. Yeah. Okay, and you can see that the distance that the boxes move, right, is in accordance lah, right, to their mass, and that's because their mass will affect the initial velocity. Yeah, so you can look at my column here. uh, the initial velocity of body A and B, right, is dependent on their mass lah. So this one is using momentum. Yeah, and when you press reset, right, every time when you press the reset button, okay, you have the initial velocity at 5. You can change it if you want to lah. Then this 5, right, will be split lah accordingly to the mass of A and B lah. If you want object at rest, no problem, you press this one and then U will be 0 straight away, and then nothing will move. Okay, yeah. Okay, so if you want to introduce the third law first, then actually you can press the button here, and then that is where it shows the law, and also it shows the force on A by B as well as the force on B by A lah. Yeah, so it's the same. Yeah, so you can let students see that it's the same. Yeah, and then after that, it's not just that, the Newton's third law also apply to other force pair as well. Yeah, so you can have normal contact force, you can have gravity, and then for the whole system, right, you can press this one, and then that will give you the force pair for for the normal contact force and the gravitational force lah. Yeah, so we also added the agent object notation that is recommended by research. The agent object notation, right, means that uh, we identify the agent of the force, meaning where the force comes from. Then we also identify the object that the force is applied to lah. Yeah, so that we don't just say friction. We don't just say normal contact force. We don't just say gravity, but we say normal contact force on A by the surface. Yeah, so then this help the students lah to identify the force pair lah. Yeah, that's in accordance to Newton's third law. Yeah, then this helps to prevent confusion, right? Some students will say, oh yeah, lor, the force pair is the normal contact force and the gravitational force, right? Because they are the same one actually. Yeah, so this helps to prevent confusion. Afterwards, right? After Newton's third law, then that's where you can also show the Newton's second law. Yeah, but for Newton's third law, right, you can show the phenomenon of the roller blade as well. You show that after this, right, actually the force that is acting on A and B, right, they will disappear. Because after they push off, right, there's no more contact already, so the force will disappear. So I have program it such that when you have body B that's present and when you have a force here, right, you can actually, the force will disappear on its own. Yeah, I add friction, and then boom. So then that's where the force will disappear, the boxes move according to their initial velocity, and then it's affected by friction. Yeah, of course you can also don't add friction, and then you can just continue like that. Yeah, then this will be constant velocity lah. Yeah, because there is no more force already. Yeah, you can adjust the velocity accordingly to your own preferences. Okay, so for Newton's second law, that is where the acceleration, displacement, and velocity time graph will appear to help students visualize the movement of the object. Yeah, so you can actually have objects start at rest, and then after that you can pull your force in. So I take away body B, you can pull your force in. So let's say 100, and then after that I can press start, and the graph will follow. Yeah. I press stop. You can see that the acceleration stay constant, velocity is a linear increase, the displacement is a curve. Yeah, then when I add friction, right, it will also the graph will be continuous lah, it will adjust accordingly. Yeah, so it's a deceleration now. You press start, the velocity will drop, displacement will still increase, and the box will stop right when it hits 0. Yeah, okay, so like that. So you can move around to show. Yeah, okay. If you want to show, smaller friction also can. So you can put input here, and then after that you can put like maybe 100. So then the net force is forward lah instead of negative, right? And then that will also be reflected. Yeah. So this one is when there is a initial velocity lah. If you don't want, then you can put object at rest, no problem. Right, so you can put object at rest, you can just start, and then after that the graph will follow as well. Yeah, now what happens right when I add friction again? Now this is the limitation of the simulation that you guys need to take note. When you add friction again, the graph won't be as consistent. Yeah, this is because of the 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 formula that I input lah. Yeah, you can only add friction once, and yeah, which explain the rationale of um why I have a acceleration, and then after that I only simulate the deceleration lah. Yeah, so when you add friction, right, there's a script here. The script is over here if you guys are interested. Okay, so what it means, right, is that when the force is 0 and I add friction, right, it will add 40. If there is 100, if the force, right, is more than 0, so let's say the force is 100, right, then the friction is 1.5 times the force. Yeah, so if I put 100, if I put 100, and if I add friction, it will be 150. Yeah, so I said it this way lah, so that you have acceleration, deceleration. Of course, if you don't want to click the button to add friction, you can use the input button as well. Yeah. For Newton's first law, you can also show the normal contact and gravity, and then after that you can show that, well, it's starting to move, right? Remain in motion at constant velocity will remain in motion, or you can object start at rest, you have normal contact, gravity, and then you can start, the object won't be moving. Similarly, you can also have normal contact, gravity, you have an initial velocity, you can have a forward force of 100, you input yourself, friction of 100, your opposing force lah of 100, you let it run. Yeah, so in this case, right, you have shown that all the forces, when they are balanced, right, but the object, when it has the initial velocity, it will continue to move at that constant velocity lor. Yeah. Right, but then what happens if I add the 100? Then it will change lah, it will shift the thing a bit. Yeah. So then in that case, I will have to go back and then I show that, well, when it's 100 and then when I have a 90, right, then that is where the constant is no longer constant velocity anymore the velocity have changed. Yeah. Okay, so that is more or less about it. Yes, I hope you guys find it useful. Yeah, thank you.